In this video, we're going to look at two learning targets. The first is I can solve systems of equations using addition, and then I can solve systems of equations using subtraction. So let's go take a look. So what you need to know. There are three methods to solving systems of equations. You may have already looked at graphing, and that's when you graph both lines to see where they meet. Remember, when you are solving a system of equations, this is what you're doing. Visually, what's happening is you have two equations that you graph, and where they intersect is the solution, that point where they cross. They make an X. Sometimes it looks just like an X. That is where your solution is. So you can do it by graphing. You can also do it by substitution, where you isolate an X or a Y, and then you plug that in, that variable into the other equation to find your answer. And then today we're going to focus on the method of elimination, where you line up the variables and you look for matching coefficients. Or you have to multiply them to make them matching, and then you add or subtract to eliminate. So let's look at our first example to see how we would do this. So in this example, it says to solve the system of equations, we have 2x plus 3y equals 20, and then we have negative 2x plus y equals 4. So the first step is to make sure that our variables are lined up. This example is nice. They gave me both equations in standard form. Remember that standard form is when we have ax plus by equals c. And this is the form that we want our equations to be in when we're using elimination to solve. So since both of my equations are already in standard form, I can go ahead and look to see what eliminates. So my x's are matched up. Let's take a look at my x's. I want to look for coefficients, or the numbers in front of the variable, that are the same. So in this example, I've got 2x and I have minus 2x. I have the same number value. And if I were just to add these, 2x plus negative 2x, that would eliminate my x variable because I'd be left with no x's. That's exactly what we want to do. We want one of our variables to eliminate. In other words, we want it to add it so that it equals 0. So when I do this, all I'm really doing is adding this bottom equation to the top equation. So 2x minus 2x is just 0x. Those cancel. 3y plus y is going to give me 4y. And then 20 plus 4 is just 24. Okay, so this 0x term really isn't here, so if you just wanted to write it like 4y equals 24, that's totally fine. And now I just want to solve for my variable. So I'm going to go ahead and divide both sides by 4, since 4 was being multiplied by the y. And when we do that, we're going to end up with 6 for my answer for y. Now, once we've found one of our variables, in this case we found y, we need to go back and find x. So what we're going to do is we're going to take one of our equations, it doesn't matter which, I'm just going to pick the top one. I'm going to rewrite it here. And I'm going to take the variable that I just solved for, and I'm going to plug that variable into my equation. So I'm going to have 2x plus 3 times 6 equals 20. And now I can solve for x. So 2x plus 18 equals 20. I want to get x by itself, and to do that, I need to undo this addition. So I'm going to subtract 18 from both sides. Those cancel, and I'm left with 2x equals 2. Okay, so now that I have that simplified there, when I have 2 times x, to undo that, we're going to divide. I'm going to put my work up here. 2x equals 2. So we divide both sides by 2. Those cancel, and x is just going to equal 1. So now I have my point. So the coordinate, oh, and I did that backwards. This answer should actually be 1, 6. My coordinate here, 1, 6, that is where the x and, or where my two equations are going to cross on the graph. That would be their point of intersection. That is the solution to this system of equations. All right, so let's take a look at another one. If you want to try this one on your own, now would be a great time to pause. You can try it and then come back and check. The directions say to solve the system of equations. Same as last time. This time I'm given 6a minus 3b equals 27, and then 2a minus 3b equals 11. Both of these are written in standard form. My variables are all on one side, and then I have that constant term on the right. We want to make sure our variables are lined up. In this case, I'm not given x's and y's, but whatever variables you're given, you just want to make sure that they're lined up like this, because really all we're doing is adding or subtracting up or down. Step 2 is to look for that coefficient that's the same. So my a's are not the same, but my b's, I have a -3 and a -3. So that number part is the same. But if I were just to try to add these like we did last time, -3 plus -3 just gives me a bigger negative number. I'd get -6. So in order to eliminate my b term here, what we can do is change the sign. And to do that, we can just multiply that by -1 or distribute a negative through. We can change the sign of all of the terms inside this equation. So if I rewrite my equation, I'd have 6a minus 3b equals 27. I didn't change the top, but the bottom would become -2a plus 3b equals -11. Now my b term, or my b variable, can cancel because -3 plus 3 is 0. So I'd be left with 6a minus 2a, which is 4a, and then 27 minus 11 is 16. So when I go to find a, we undo multiplication by division, and a is going to equal 4. So I just solved for my variable. Now my last step, if you'll remember from the last example, is to substitute that answer back into an equation to find the other variable. Again, it doesn't matter which equation you choose. So if I pick this top guy, I'm going to put my work over here. I've got 6a minus 3b equals 27. I'm going to take my answer for a and I'm going to plug it into a over here. So 6 times 4 minus 3b equals 27. 6 times 4 is 24. And now we want to get b by itself. So since I have this 24 up front, it's really being added because it's a positive. So I would subtract 24 from both sides. So if I kind of move my work over here, those are going to cancel. I'm going to be left with -3b equals, and then 27 minus 24 is just 3. To undo multiplication, we divide. So we divide both sides by that -3. Don't forget that negative. And I end up with -1 for my answer for B. So here we can see our answer is at 4, -1. If I were to graph these two systems, we would see them intersect or cross at the point 4, -1. That is the solution to that system of equations. If you need more information on this topic, you can check out the Learning Target spreadsheet for additional resources, videos, and practice.